In this video, we're talking about logarithmic functions. So just as a reminder, we're connecting this to exponential functions. So let's look at those graphs. So I graphed them both here. And really, you could get all of the graphs of y equals b to the x from this one and use the reflection, but I might as well include this one as well. Okay, and for both of those, whichever one you use, the function is 1-to-1, and that means that it passes the horizontal line test. So for every x input, there's exactly one y output. There can never be more than one y output for any given x input, and vice versa, so that no two x's are going to have the same y output. Okay, so to find the inverse function, just as a reminder, we switch the x and y and we solve for y. That's how we do it algebraically. And the same could be said graphically as well, but we'll look at the graphs separately in a minute. So if we looked at f of x is equal to 2 to the x, we want to switch that to have a y instead of f of x. And then we're going to switch the x and the y. So we have x equals 2 to the y. And we want to solve for y, but we don't really have like a mechanism for that or a tool for that at this point. So, instead we're going to make up a new function, and that's where the log comes in. So it's kind of weird because we haven't really had any exposure to this function much in our lives, whereas every other kind of function we've dealt with, typically we've seen along the way, whether it's square root or fractions or that sort of thing. But log is relatively new, and I think it makes it less comfortable for us. So we're going to say that y is the exponent that 2 must be raised to in order to get x. And we call that a logarithm. And so let me define it here a little bit more rigorously. So we define the expression log base b of x to mean the exponent to which b must be raised to get x. And then we say it out loud, kind of like I just said, either log base b of x or the log of x base b. I usually use the first, but it really doesn't matter. So using this notation, we can finally get the inverse function that we're trying to find above. So it means that f inverse of x is equal to log base 2 of x. That's the inverse of f of x is equal to 2 to the x. So in general, we can say that y equals log base b of x. B is going to be a number. That's equivalent to x equals b to the y. So this is really important when it comes to logarithmic functions. And we call this version, because they're equivalent, we call this version the logarithmic form, and we call this version the exponential form. And it's important to be comfortable switching back and forth between logarithmic form and exponential form. So let's evaluate each of these. So we're trying to get a number answer, and these are not such that you can just plug them into your calculator. This one you could. But most calculators do not allow you to change the base here. Some do, but a lot don't. So you should be prepared to evaluate these without the use of a calculator. So what we're going to do, well, this is 2, and here's why. Because I can rewrite this in exponential form. So if I just said that this was equal to y, then I would rewrite this as 3 raised to the y, because the base is 3, raised to the y is equal to 9. And I'm trying to find out what y would be that solves this equation, really. So y would equal 2, and we did this in some previous videos where we would solve an equation like this. So you can always go back to those videos to review solving some exponential equations where they have the same base. All right, so that's how we got that answer. So similarly here, we're going to take this, you could call it y over here. So we're changing this logarithmic form to its exponential form equivalent. So this is equivalent to 10 to the y is equal to 1,000. So I'm looking for a number for y that when I raise 10 to that, I get 1,000, and that would be 3. All right, and then over here we have, this is actually going to equal 0, which kind of feels odd, but what happens is that when we change this to exponential form, we're going to get 7 raised to the y is equal to 1. And you can call this whatever letter you want. You call it a or x. I just called it y. But it's not having to do with the graph or anything like that. Just a random variable I chose. So 7 to the y is equal to 1. The only way you raise something to a number and you get 1 other than 1 is if that exponent was 0. So that's what we have here. And so a lot of what we work with with log functions can be kind of solved or evaluated or helped along by switching forms. So similarly here, we're going to rewrite the following in exponential form. So this is already written as an equation type of thing. And so I want to switch that form to be exponential. So here's my base. And then I think of it as just switching this number with this number and dropping the log. So I get 3 is the base, 3 is the base here. And then I switched the X, the A and the 17. That's how I think of it. And then that's the answer. We're not trying to solve this right now. We're just trying to rewrite it, the form. This actually is the solution of this equation. Similarly, over here, I have base 2. This exponent would be here and equals the 5. So I think of this as being like 2 raised to something, but I need to switch what it's raised to. So it's going to be t to 2 to the t is equal to 5. And then over here, this one is already, there's no variable, there's nothing to solve for. It's already a true statement. So we've got 9 is going to be the base, and then we switch the 3 and the 1/2. So we've got 9 raised to the 1/2. That is equal to 3. And that is true because square root of 9 is 3. So last one here, we're going to rewrite the following in log form. So now we've been given exponential form and we want to switch to logarithmic form. So here is the base, but now it's going to be the base of the log. And again, I'm going to switch these two numbers. So I've got log base 5 of 25 is equal to 2. Remember, whatever this is equal to, this is saying that if we were to read this out loud as how it's defined, log base 5 of 25 is equal to the exponent to which 5 must be raised to in order to get 25. Kind of weird. I don't know if it helps to phrase it that way or not, but you should be comfortable switching forms. That's what you want to make sure you're able to do after this. Similarly, over here, we've got 9 to the x is equal to y. We switch that to log form by taking log base 9 of y is equal to x. And then the last one here, the log base 1/2, and you can't have fractional bases for your logs, is of 32 is equal to -5. That's equivalent to that exponential form up there. So that's the intro to logarithmic functions, and we'll work more with them as we go through these sections.